Jupyter Notebook. Yeah, I have to switch between windows if to see. Okay, cool. So this presentation is about an importer we did for the Bonsai database, which is an output of the Getting the Data Right project. If you were at Brightcon last year, you probably had listened, like Valentin, my colleague, talking about some of the early results of this project, which where we meant to produce an open source database, and all the code to generate the database is also open. We are not finished with the database. We are supposed to finish next year, so hope the best to have everything in line. This database, at the moment, we focus only on greenhouse gas emissions, but we have a few extensions more in the line and available. But for funding reasons, we started with the greenhouse gas emissions and hope to get some more funding to extend the work. The database follows a consequential paradigm. So in order to be able to use the output of this project in Brightway, we needed an importer like any other importer. And we decided to use the IO table backend or from Brightway 2 data, which Chris created to work with the input-output tables. These tables usually don't have metadata on the exchanges, and they have a lot of data. It had a lot of exchanges, so they are quite dense. And in order to save memory, they are not stored as a normal, like as in an SQL database, at least not in its entirety, as you would do for a event, for example. So based on the existing Exadebase importers, we created a generic importer. So I started work with a simple example of what could be like an input-output table, which means that there are actually two importers. One importer for input-output tables, which is more generic, and then one more specific importer for the Bonsai database, which is based on this importer. So if you run the code that it's in the servers and start like a normal project, currently is linking to the version of Biosphere flows from Event 3.10. And here I created an example just to test of a possible input-output table. So here you'll see like imagine like a very simple input-output table where you have like two activities that produce two things, and they're actually both in Denmark, and they have some emissions of CO2 and methane, and maybe some stuff which is non-standard emission, which you would not find usually in the Biosphere database, and some land occupation, for example, and then some final demand. For those who are maybe not familiar with input-output tables, they usually include not only what is like recipes of what is produced, but also how much societies consume. So usually you would have like some data on the consumption of different products by households, government, capital formation, and so on. And maybe they come also with some emissions. So essentially here, what I'm creating is just like defining a data frame, which I already executed the code before because I wanted to be sure that it was working. But essentially it looks like this. So you have like the production activities and some final demand. And once you have like this defined as think, if I say like, yeah, you see like all is actually defined as a sparse data type, because usually there are a lot of zeros and we don't want to store zeros because they take a lot of place. So how this importer works is that if you have like something defined as a, imagine like as a data frame like this, you would create like store it intermediately as CSV files, which I did before. So it's actually this data is the export of this example that I created here, and it takes very little space. Actually, it's very small. But yeah, it's a way to organize the data to be ready for being imported by the importer. It also needs some metadata. For the moment, I'm just defining the metadata as a JSON file. So if you open, well, not the one of the bonsai, like one of the example, it would be something like this. Like each product has like needs the unit and the name, and also the emissions or like elementary flows need also like some sort of definition of the compartment or context in which they are emitted, and also of course the unit. Notice here that we are using non-standard units. A ton is not the same thing. It's an American ton. It's not like a metric ton. And yeah. So if we click this tidy tables command function, it will create this. Yeah, you see, like this has been like updated. It creates these tables that later we can just import. Okay, yeah. Before importing, we would need like to define like a mapping between the elementary flows that I'm using in this database that I'm just creating, like what I call CO2 air. So we need to associate it to the code of what the the current biosphere database defines as CO2 air. So I just search for CO2 and methane. I mean, you don't need to do this on the fly. You usually prepare this beforehand. So these are, and then you just run the importer, which has another Brightway importer. And once you run this, you can actually access the database, and you see like the different, I mean, this works as any other activity using the input-output, the IO table backend, and we can calculate like the footprint of this example that I've just invented. As you can see, the technosphere matrix is what you would expect. It's the same thing as we have defined previously. Now, yeah, notice only that it uses actually pint to handle some conversions, like for example, these tons of CO2, like American tons, instead of, and also creates an additional, if you look now into the existing databases, we will see that there is like an additional biosphere database with the code, with the stuff which is not present in. We look for the IO database biosphere. We should only find one thing here, which is this carbon dioxide accelerated thing that I invented, and it's not part of biosphere. So it will automatically create an additional biosphere database with this stuff. And going in for the example, we just follow the same process. The only thing is like this creating of tidy tables, you don't need to do it because we did it for you. So this is what you find in the bonsai data, essentially here. And then you can run the importer, apply the strategies, write the database. It didn't take actually long for me to do. And then we can just test the results. So we can see, for example, that Bonsai has 50 different locations and 783 products, a total of 34,567 activities. And if we take like an activity, like let's say like a landfill for other non-ferrous metals, this is very boring. Okay, cauliflowers and broccoli, why not? And we can calculate the LCA, like for example, the carbon footprints using IPC 2021. Yeah, you better use like a PyParadiso to calculate these matrices because otherwise it takes really long. You can see like the average density, well, it's just a curiosity, and then you can, I don't know, do any kind of contribution analysis as you would do in Brightway. This is, for example, most of the carbon footprint of cauliflowers seems to be from N2O. Okay, maybe because of the field emissions of cauliflower production. And we can see, yeah, most of it seems to be like direct emissions from in the field. And essentially that's it. We wanted to create like a first version that you can start playing with it, and you can send us feedback. I haven't really thought about which email, but you can always email at me at well, I'll put it in an updated presentation. But yeah, it would be great if you start playing with it and find things that think that should be changed or potential bugs, and help us to improve the database, because I mean, the idea is we're trying to make it easier to incorporate the input from other users, from people that want to improve the database, and this will be part of managed by the Bonsai organization in the next year. So yeah, the idea is to do something collaborative. So with that, I'm open to questions if we have time. We stop sharing.
Thanks a lot, Miguel. I think we should open up to questions for people from the online audience first. So whoever wants to have a question, please raise your hand. And Karen, please just select people. Oh. Okay, first come, first serve. Anyone who's in the online audience who has a question, feel free to unmute yourself and go ahead and ask.
Hello. Thank you for the presentation.
Can you turn off your own speaker, please? Fabian, you were fine. You just we had some feedback because your microphone was listening to your own speaker.
Well, I try to speak anyway. Can you make a bridge between these input-output tables and databases like EcoInvent in the same calculation?
A bridge. I mean, you could create a hybrid input-output table using the output of like this input-output table and EcoInvent. I think there are people working on this, but if by a bridge you mean like creating a hybrid LCA database using this one and something like with more process-based data like EcoInvent, yeah, it's definitely possible. I think there's people working on it. Not
Yes.
For the moment, we're focusing on
Using
finalizing the
input-output
database.
tables to create market activities.
Sorry, can you repeat again?
To use the input-output tables to create market activities.
Yeah, I mean, you can use it as however you would. I mean, there is all the market activities are based on essentially trade data and and production. So yeah, you could use it for if you want to use the market composition of this database as you would use it as you see fit. I mean, it's open.
Okay, any more questions from the online audience? What about here in the room? Yeah, feel free. You need to come up, though. Just be relatively close to the microphone.
So one question regarding input-output tables is that at least in the US, they are updated after a long amount of time. And like my colleagues who are working with input-output tables for doing environmental impact analysis face this as a huge problem. So how is the Bonsai project trying to or does it try to solve this problem in any way?
I mean, it is. Thanks for the question. What we have created is data pipelines to pick the data from because to pick the data as soon as it comes, as soon as it is generated. So imagine like some country will update their supply use tables and provide it. Then we can incorporate it and use it. But we cannot invent the data, so we just use the data, like have a pipeline ready. So when the data is ready, we can incorporate it and generate a new version. And the idea is to do everything as automatic as possible. I should say also that this is like an input-output table in what's called hybrid units. So it's not a purely monetary table. It has stuff in physical units. Like the broccoli that you saw there, it was kilograms of broccoli. It was not like euros of broccoli. But yeah, this is like a problem. Like the data, like the age of the data is a known problem, but it also affects many other databases, even process bases. Yeah.
Any other questions? This is a huge new public database. Feel free. You need to come up. Hi, Miguel.
Hi, Miguel. Thanks for your presentation. I was wondering on a technicality that you mentioned, like you said, you're storing the IO table as a sparse matrix because they are sparse. But in my experience, I don't know, is Bonsai sparse? Because like if you look at something like Xiobase, it's just incredibly dense. There's very few zeros in there. And I found them actually using sparse matrices to be quite slow. if you store dense object. Can you comment on like is Bonsai like what kind of resolution are you talking about? Is it comparable to Exibase or?
Yes, I think the density of the matrix it was like 11%. Yeah, so it's still. I mean, there's still a lot of zeros. Maybe because of the markets, but internally, anyways, Brightway uses a sparse data format to manage. Well, so essentially, like what you saw there sparse is only like because when we convert this into like a temporary, like some files to be then uploaded, we just don't want to store the zeros. So like once imported, it uses the normal format that Brightway uses to calculate stuff. So it's not slower in that sense. It's
But
just
does that mean
if it's slower, yeah. Sorry, Chris.
does that mean that you are purposely filtering out very small numbers from the I/O tables to reduce the density?
No. Not. I'm not filtering very small numbers, but maybe that would make sense. But no, I'm not filtering them. I was just taking the as it is produced the tables. I'm just converting it into a sparse data format and storing it in. Well, it's actually like the algorithm right now produces a pandas data frame in sparse data format. So I'm just storing it as the non-zero values as a compressed CSV file.
So when you say like it is still relatively sparse and it's partially because of markets, that means you're using like a equivalent type form for markets, explicit markets instead of the implicit markets usually used in I/O.
Yes.
Is that correct? Yeah.
It is correct. Yeah, it has like market activities. Yeah.
Okay. Thanks.
Yeah. Thanks.
Okay, I think we have time for one more question. And maybe someone online. Maybe you could remind me, is this something which we can use now? Like, is the entire pipeline up to the data API available? Or is this still a prototype?
If you can run the entire workflow to create these tables that I'm showing here.
Yeah, well, I understand we could run it like today during the conference, but is this now in general availability?
Yeah, it's in GitLab. I think nobody has tried yet to do it, but it should be possible. Yeah.
Okay, thanks so much, Miguel. So really amazing work by you and the team.
Thanks.
Okay. I hope this is going to work.